Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use this graph of the derivative of function f at x to graph the function f at x. So as per the problem, the following graph represents the derivative function prime of f at x of a function f at x. Now determine the intervals where f at x is increasing, the intervals where f at x is decreasing, and x coordinates for all local extrema of f at x. Assuming f at 0 is equal to 2, make a rough sketch of graph of f at x. So we are given this graph of prime of f at x, and we have to use this graph to graph the function f at x. So first let's analyze the given graph for prime of f at x. So as per the graph, the prime of f at x is a straight line which crosses the x-axis at 4. Now to the left side of this x-intercept, the prime of f at x is a positive value because the graph is above the x-axis. And we know if the prime of f at x is greater than 0, that means the function is increasing. So in this case, the function is increasing over the interval negative infinity to 4. So that's our first observation. Now we can also write it in inequality notation as x is less than 4. Now on the right side of this x-intercept, the graph goes below the x-axis. That means prime of f at x is less than 0 to the right side of 4. So that means this function is decreasing to the right side of x equals 4. So that means the decreasing interval is 4 to positive infinity. And we can write this in inequality notation as x is greater than 4. So this function has only one increasing interval and one decreasing interval. Now we also have to find the x coordinates for all local extrema. So in this case, at x equals 4, the function changes from increasing to decreasing as we go from left to right. That means there is a local maximum at x equals 4. So there is a very important concept we need to understand and memorize, that whenever the graph changes from increasing to decreasing, that means there is a local maximum. So now we can use this information to graph the function f at x. So as per the problem, so f at 0 is equal to 2. So that means one point that lies on function f at x is 0, comma. So this is the y-intercept, and we can show it on this grid as this point. Now we know that there is a local maximum at x equals 4. Now we do not know the y value for this point, so we just know that on the left side of this point, the graph is increasing, and to its right side, the graph is decreasing. So that means on the left side of x equals 4, the graph is sloping upwards from left to right, because in that case, the slope of the tangent of prime or f at x will be positive or greater than 0. So we can show the graph of f at x as, so we can show it as a curve that passes through this point, and it keeps going up and it peaks at x equals 4. And then on the other side, the graph starts going down because the slope of the tangent is negative, or prime of f at x is less than 0. And then it just goes down. So this can be a possible sketch of function f at x. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So you have to be very careful in analyzing the given graph for prime of f at x to identify the increasing interval, the decreasing interval, the local extrema, and then use all of that information to graph the function. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.